Alright. Okay, how about I give you this? Okay, I just won't delete that cyclic powers of I. What if you're asked to get the value of I to the 124th? Okay, you divide the exponent. What is the exponent here? 124, right? This one, the exponent is 124. So you divide that by 4. So what is 124 divided by 4? 31. Okay, and we don't have a remainder. So we simplify this. Uh, I to, okay, so I to the 4th to the 31. Remainder is 0, so I to the 0. Or we just don't write that one. So this is just 1 to the 31 is equal to 1. So I to the 124th is equal to 1. Okay, why don't you try this? What if you're given I to the 201? What is the value of that? Okay, I to the 4th to the 51. So 201 is divisible by 4, are you sure? Yeah, it should be 50, right? It should be 50. Yeah, and then you have a remainder 1. Because 4 times, see? 4 times 50 is 200, but it's 201. So that means the other exponent would be, you will write the other exponent to with another I raised to the power of 1. So this would become I, okay, I to the 4th is 1, right? 1 to the 50 times I, so this is just 1 times I is just equal to I. Therefore, 201 is just equal to I. Okay. You want to do more on this before we proceed with addition, operations in complex numbers. Okay, so what if I'll give you I to the 6, I to the 15, then I to the 62. Okay, try to solve this. So you can break down I to the 6 as I to the 4th times I squared. Are you still are you familiar with the law of exponents? You should know those. Yeah, you should know the law of exponents first. If, let's say for example, okay, if you multiply two terms, let's say this one, a and a of the same base, and the exponents are m and n, so if you multiply them, then you can just copy the base a and add the exponents. Okay, so that one is the, and then if you have a term, let's say a to the m raised to the power of n, which is the power to power rule, this is just a times m times a to the m times n. All right, and if you divide terms with the same basis, like let's say a to the m over a to the n, just copy the base a, then you subtract the exponents m minus n. All right, okay, so you should remember those, so we can apply those here. So we have the same basis I, and then we just add the exponents. 4 plus 2 is equal to 6, right? So this is just equal to I to the 6, and I to the 4th is equal to 1, so that is 1. Then I squared, this one, equal to negative 1. So 1 times negative 1 is just equal to negative 1. Therefore, I to the 6 is just equal to negative 1. Alright? You understand that? Then, okay. So I to the 15th. When you divide 15 by 4, how many 4s are there in 15? 3. So you can do like this. I to the 4th to the 3, right? Because there are 3 4s. And what is the remaining? You just do this. 4 times 3 is 12, right? Then 15 minus 12. What is 15 minus 12? Then the remaining is I cubed. That's how you're going to do that. And then you simplify. I to the 4th is 1. So that is 1 cubed. And then I cubed is this one. You already have that one. Times negative I. So this is just 1 times negative I, which is equal to negative I. So you have to remember this, alright? The cyclic powers of I, and also the law of exponents. These are really helpful. Okay, and then for I to the 62, you divide 62 by 4. How many 4s are there in 62? 15. So you'll do like this. I to the 4th to the 15, right? So what is 15 times 4? 15 times 4. 60. But you have 62 here. So what is the remaining exponent? 62 minus 60. Yeah, so you multiply this by I squared. The exponent should add up to 62. Alright? Then you can plug in all the values. So the value of I to the 4th is 1. Then 1 to the 15th. Times I squared is negative 1. So this is just 1 times negative 1, which is negative 1. Alright. Do you want to try some problems on your own? You're fine? Okay. Alright. Then we can proceed with addition, subtraction, multiplication, and division of complex numbers. Alright, so let me delete this. Okay, add, subtract, multiply. So let's add first. Now, in adding complex numbers is in the form of this: A plus B I. So A here is the real part of the complex numbers. The one with the imaginary number I, we call this as imaginary part. Imaginary part. Alright? Then we add. Okay. What if we're given this one? 2 plus 5i plus 4 minus 7i. So when we add complex numbers, we will only add the real parts together, or group them together, and then we add the imaginary parts separately. So add or subtract. Okay, so let's get rid of the parentheses first. So this would become 2 plus 5i plus 4 minus 7i. Then we group like terms that are alike. We have the constants 2 and 4, so that is 2 plus 4. And then we group 5i and negative 7i, so that is plus 5i minus 7i. And then we simplify. 2 plus 4 is 6. 5i minus 7i is negative 2i. So this is the answer to that. Okay. Then, okay. How about we're given this one? 5 plus 2i plus 3 plus 7i. Okay. you get rid of the parentheses first. So this is 5 plus 2i plus 3 plus 7i. Then you group like terms. 5 plus 3 plus 2i plus 7i. So this is 8 plus 9i. Okay. Now let's subtract. No questions on addition? Okay, you're welcome. So we go to addition. No, subtraction. So what if you're given 4 minus 8i minus 3 minus 5i? Okay. The same process with addition is just you have a negative sign here, minus. So you need to distribute the minus sign, the negative, to the expression inside the parentheses. So let's get rid of the parentheses first. So this would become 4 minus 8i. The negative times 3 is negative 3. So this is just negative 1. So negative times negative 5i is positive 5i. Alright? And then now we can group like terms. So 4 goes with negative 3. So that is 4 minus 3. And then negative 8i plus 5i. Then we simplify further. So 4 minus 3 is 1. Negative 8i plus 5i is negative 3i. So this is our answer here. Okay. Okay, what if we're given this one? 5i minus 3 plus 8i plus negative 4 plus 7i. Okay, the same process. We get rid of the parentheses, so this would become 5i. We distribute the negative sign. Alright, so this is negative 3 minus 8i. Be careful of the negative sign. Then this one, so this is positive times negative is negative, so negative 4 plus 7i. Then we group like terms. Negative 3 goes with negative 4, so this is negative 3 minus 4. And the other 3 imaginary parts go together. So this is 5i minus 8i plus 7i. So this is negative 7 plus, okay, 7 plus 5 is 12. 12 minus 8 is 4. So this is negative 7 plus 4i. Okay, so let's no questions on addition and subtraction. Okay, so let's move on to multiplication. What if we're given this one, 3i times 7i? So we just multiply them. Alright, so when we, yeah, now I will just have some ginger later. Okay, so when we multiply the real numbers and then the imaginary numbers. Alright, so in this case, we don't have operator sign. We don't have addition, subtraction in between. So we can just simply multiply. So 3 times 7, this is 21. Right? And then I times I is I squared. Alright? So the answer is 21i squared. But I squared is equal to negative 1. Remember the cyclic power of I? So 21 times negative 1, this is just negative 21. So this 3i times 7i is just equal to negative 21. Okay, but what if we're given this one? 5i times 3i minus 7. Do you have an idea how to do this? Okay, so it should be 5i times 3i. Copy the operator sign minus. So minus 5i times 7. So you just simply distribute 5i to each of the terms inside the other parentheses. Then we simplify. 5i times 3i is 15i squared. right? Then 5i times 7i is 35i. Then we simplify. 15 times I squared is -1 minus 35i. So this is -15 minus 35i. So this is our answer, final answer. Okay. Okay, what if you're given this one? I'm deleting. Okay. Okay, so what if you're given, okay, this one. 2 minus 4i times 3 plus 5i. Do you know FOIL? So you, okay, you just FOIL. So you multiply this one. 2 times 3. Okay. Then -4i. So plus -4i times 3. So you should review on FOIL method. Then 2 times 5i. 2 times 5i. Then -4i times 5i. Then we simplify. 2 times 3 is 6, plus 4i times 3 is 12i, plus 2 times 5i is 10i, plus 4i times 5i is 20i squared. Okay, you're following? You got that? Oh, I think I missed the negative sign here. It should be negative, sorry. Okay, this one should be negative. So this is 6 minus 4, okay, 10i, 12i, okay, then minus 20i squared. So this is just 6. We group like terms. 12i goes with 10i. So -12 plus 10 is -2i. Minus 20 times I squared is -1. So this is just 6 minus 2i plus 20. Then we simplify further because 6 and 20 are like terms. So 6 plus 20 is 26 minus 2i. So this is our final answer. Alright, then, okay, what if you're given like this, in this form? 3i times 6i times 2 minus 3i. Alright, in this case, let's multiply this first. 3i times 6i, that is 18i squared, right? Times 2 minus 3i. Then we distribute 18i squared to each of the terms inside the parentheses. So this is just 18i squared times 2 minus 18i squared times 3i. Then we simplify. 18, what is 18 times 2? Okay, 36i squared minus, what is 18 times 3? Okay, so this is minus 54. I squared times I is I cubed. And then we simplify. We know the value of I squared. What is the value of I squared again? Okay, so we multiply that 36 by -1 minus 54 times, what is the value of I cubed? Yeah, -I. So you should memorize all those 4. Okay, then we simplify. So this is -36 plus 54i. So this is our final answer. Alright, then, okay, I'll give you 2 more. How about this one? What if you're given this one? 4 minus 5i squared. Okay, how are you gonna solve this? it's a perfect square. Yeah, so you can write this as 4 minus 5i times 4 minus 5i. This is a perfect square, so the middle term, no, the middle term doesn't cancel out, so we just FOIL this. So that is 4 times 4 plus this one, negative 5i times 4 plus this one, 4 times negative 5i plus this one, negative 5i times negative 5i. Then we simplify. 4 times 4 is 16. Negative 5i times 4 is negative 20i. Then 4 times negative 5i is negative 20i. Then negative 5i times negative 5i is 25i squared. Then we simplify further. Negative 20 goes with negative 20. So this would become 16 minus 40i plus 25 times i squared. I squared is negative 1. So this is just 16 minus 40i minus 25. And then we can simplify further because 16 and negative 25 are alike. So what is 16 minus 25? Okay, so this is negative 9 minus 40i. This is our final answer. Alright? Okay, so what if, okay, I think 2 more or 3 more. So what if we're given this one? 7 times 4 plus 3i minus 5 times 2 minus 6i. That one. What should be the first thing we're gonna do? First thing we... Yes. So, okay, distribute first, then simplify. Okay, so that is 7 times 4 plus 7 times 3i minus 5 times 2 minus... Okay, minus 5 times 2 plus negative 5 times negative 6i. Or you can just simply add plus negative 5 times 2. So it won't be confusing. Then 7 times 4 is 28. 7 times 3 is 21i minus 10 plus 30i. Okay, and then we simplify. So 28 goes with negative 10. So 28 minus 10 is 18. Then 21i goes with 30i. So this is 51i. So the answer is 18 plus 51i. Okay. Okay, what if you're given like this? Let's say we have 4, okay, this one. 4 plus square root of negative 25 plus 3 minus square root of negative 81. Do you have any idea? Yes, you solve the square root first. So this would become, okay, this is 4 plus, you can write this as square root of negative 1 times 25, right? As well as the other one, 3 minus square root of negative 1 times 81. Then we simplify. So this is 4 plus, alright, square root of negative 1. What is square root of negative 1? No, square root of negative 1. Remember the cyclic powers of I? I is equal to square root of negative 1. Right? Square root of a negative number. So it's I. So this is I. Then square root of 25. 25 is a perfect square. That is 5. Right? But you can write this as 5i. So the real number should be written first. So this is 5i plus 3 minus square root of negative 1 is I, then square root of 81 is 9. So this is 9I. Then now we can simplify. We get rid of the parentheses, so this is just 4 plus 5I plus 3 minus 9I. Then we group like terms, so this is 4 plus 3 plus 5I minus 9I. So this is just 7 minus 4I. So that is our final answer. Okay, one more. No questions on this? Okay, so another one. So what if you're given this one? 7 minus square root of negative 9 minus negative 4 plus square root of negative 36. Okay. Again, okay, what are we going to do? Okay, yeah. So this would become 7 minus square root of negative 9 is 3I, right? 3I minus negative 4 plus square root of negative 36. What is square root of negative 36? 6I, because you have a negative 1 there. So it's 6I. Then we simplify. So this is 7 minus 3I. We distribute the negative sign. So negative times negative is positive 4. Negative times positive is negative 6I. Then we group like terms. 7 plus 4 is 11. Then negative 3I minus 6I is negative 9I. So the answer here is 11 minus 9I. Alright. Okay. So what if you're given this? 3 times 7I raised to the power of 2, or squared. So what are we going to do here? You start with the terms inside the parentheses first, or the brackets. So 3 times 7. 3 times 7 is 21I. Then squared. So this would become 21 squared times I squared, right? So what is 21 squared? Yeah, so this is 441. I squared is negative 1, so this is negative 441. Alright, so that's all for add, subtract, multiply. Now we work on division. So how to divide complex numbers. Okay, so when we divide with complex numbers, you have to be careful with, like, say for example, if your denominator is square root of negative 1. Okay. Alright, so let's try some simple division first. So what if you're given 7 plus 3I over negative 5I? Okay, are you familiar with the term conjugate? Okay, when we say conjugate, that means opposite. So in division, we will consider the terms, or the terms in the denominator, or the bottom, or the terms in the bottom of the fraction. This one is the fraction. All right, so the middle, the denominator here is negative 5I. It's negative I. So we can just multiply this by the conjugate, or negative I, which is positive I. All right, conjugate meaning the opposite sign of the imaginary part of the complex number. So we just multiply that, and then this would become I times 7 plus 3I, and this one is negative 5I times I. Okay, then we distribute I. So this is 7I plus 3I squared over negative 5i squared. Then we simplify. So this is 7i plus 3 times negative 1 over negative 5 times negative 1. And this is just negative 3 plus 7i over 5. Okay. So this is our answer. Okay, how about we're given, okay, the questions on this. No questions on this. You don't have questions. Alright. Okay. Alright. Okay, so what if you're given 2 minus 6i over 4 plus 8i? What is the denominator here? Okay. And then what are we going to do here to divide this? You have 4 plus 8i. So 4 plus 8i, the conjugate would be 4 minus 8i, because the sign here of the imaginary part is positive. So you will change that to negative. So we multiply by 4 minus 8i over 4 minus 8i. Alright, then, okay, so this would become 2 minus 6i times 4 minus 8i over 4 plus 8i times 4 minus 8i. Then you FOIL. You FOIL this. So this is 2 times 4. 2 times 4 is 8. Then negative 6i times 4 is negative 24i. Then 2 times negative 8i is negative 16i. Then negative 6i times negative 8i. What is that? 48. So plus 48i squared. And then the denominator, we FOIL this too. 4 times 4 is 16 plus 8i times 4, that is 32i. Then 4 times negative 8 minus 32i. Then 8 times 8 is negative 64i squared. And this cancels out. And we can simplify. So 24 plus 16. So this is 8 minus, what is 24 plus 16? That is 40. 40. So 40. Then 40i. Then plus 48 times negative 1. Then this is 16 minus 64 times negative 1. Then we can further simplify this. So this is 8 minus 40i minus 48 over 16 plus 64. So this is just 8 minus 48 is negative 40 minus 40i over 16 plus 64 is 80. And then we can further simplify this. Let me delete this one, the first one. Okay, so we have 40, negative 40 minus 40i, 48i over 80. So all of these are divisible by 40, right? So this is 40, sorry. 40i. So we divide both the numerator and denominator by 40. So this would become negative 1 minus I over 2. So this is now our final answer. Okay. Let me give you another example. So what if, okay, what if you're given this one? 8 over 6 plus I. So what are we going to do here? Okay, that's right. So we multiply by the conjugate. So this would become 8 times 6 minus I over 6 plus I times 6 minus I. Then we distribute. 8 times 6 is 48 minus 8I over, we FOIL this one. 6 times 6, 36. This is 6I minus 6I, then plus I squared. This cancels out, so we have 48 minus 8I over 36 minus 1, because I squared is negative 1. So we have 48. Okay, hold on. I think I made a mistake. Okay, this should be minus I squared. So this is plus 1. So this is 48 minus 8I over 37. So this is our final answer. We cannot further simplify that. Okay. You understood it a lot more? You're welcome. Okay, I'll give you this one before I let you go. Okay, can you solve this? Square root of negative 16, square root of negative 24. Can you give me the answers? Square root of negative 6 times square root of negative 3. Then negative 15 minus square root of negative 200 over 20. Can you give me the answers to this? Okay, so this is 4I. You're right. And the next one. So take note that 24 is not perfect square, so you can look for factors of 24. Yeah, but they're still smaller than 12. So this would become negative 1 times, what are the factors of 24 that has, that is a perfect square? So 4, right? So 4 times 6. So this would become, square root of 4 is 2. Square root of negative 1 is I. And 2I square root of 6. Okay, this one, next one. Square root of 6 and square root of 3. Yes. So what are you going to do here? What is square root of negative 6? There's no perfect square here because 6 and not 3. So you can write this as square root of negative 6 is I square root of 6, right? Times square root of negative 3 is I times square root of 3. And then you can just multiply them. I times I is I squared. And then square root of 6 times square root of 3 is square root of 18. Right. And then 18, you can break that down as square root of 9 times 2. Right? Then this would become I squared times 3 square root of 2. And I squared is equal to negative 1. So negative 1 times 3 square root of 2. So this is just negative 3 square root of 2. So that is our final answer. Okay, how about the last one? Negative 15 minus square root of negative 200 over 20. Yeah, you can factor it. Okay, so this would become negative 15 minus, this is negative 200, right? Square root of negative is I. So we put I outside first. And 200, we can write 200 as 100 times 2, right? Because 100 is a perfect square over 20. And this would become negative 15 minus, square root of 100 is 10. So this is 10I square root of 2 over 20. And all of them are divisible by 5. Yeah? So you divide by 5, divide by 5, divide by 5. So negative 15 divided by 5 is 3. So that's negative 3 minus 2I square root of 2 over 20 divided by 5 is 4. So the answer is negative 3 minus 2I square root of 2 over 4. You understood? No? Oh, that's great.